Hello everyone, I am Jeevan Raj, a certified data science and analytics coach working at Imarticus Learning. Today we are diving into the fascinating and crucial topic analyzing the aviation accident to improve the flight safety. We will be exploring the aviation accident database for the National Transportation Safety Board (NTSB), which contains the detailed record of aviation accidents since from 1962 on date. Stick around to see how machine learning will help us to uncover the patterns and insights that could potentially save the lives. In this project, we'll be discussing about what exactly the database we want to extract from, what are the various data manipulation operations that we want to perform, and then what are the EDA, exploratory data analysis operations that can be done, and how we can extract the patterns or information or the insights from the dataset, how to perform the predictive modeling, and what are the different algorithms needs to be used. So various factors we'll be discussing step by step. So in this aviation dataset project, it is a comprehensive collection of aviation accident records from around the world. The NTSB is an independent federal agency in the United States that investigates the transportation accidents, including those in the aviation. By analyzing the reach of this dataset, we aim to enhance the understanding of the aviation safety and reduce the accident going further. Let's break down the objective into 4 or 5 different parts. The first thing what I will do, I will start investigating and analyzing the aviation accidents to understand the cause and as well as consequences. Next, I will start explaining you how to identify the specific plan or specific plane or the engine type that poses the highest risk. Now we are going to examine whether the condition is contributing the highest impact for the accidents, or analyzing the relationship between the number of engines is affecting the aircraft or the survival of the particular human, or will also access the which type of flight used to take off, or it used to claim, or it was landing. At what time there is a risk factor is higher, we will be discussing it. Without further ado, let me start explaining the workflow that we are going to follow. First, we are going to analyze the data. Then we start collecting the data from the different source where the data is stored, and then we start to the exploratory data analysis EDA. Once we done the exploratory data analysis, what are the various components that is present in the exploratory data analysis, whereas we want to clean the data where the data will be unclean. We want to clean the data. We want to do some visualization to find the insights that are present in the data. Then we start building the statistical summary and we do feature engineering. What are the various feature engineering will be done? The first thing is we are going to handle the missing values where your data will be not completely cleaned. Some of the information may be missing. So we are going to handle the missing values, handling the outliers and feature scaling. All the feature will not be in the same scale. So we want to perform the feature scaling to bring all the information to the same units. While handling the outliers, we have different types. One is identifying the outliers and as well as treating those outliers. Once we have treated and identified those outliers, will be sent into the random sampling, and then we perform the predictive analysis, and then by using the various algorithm like logistic regression, decision tree, random forest or any other ensemble learning, we will be building the model and then we will try to give the conclusion. So let's begin with the data dictionary. So this data dictionary tells that where we have event ID. Event ID indicates the unique identifier of an aviation. Next we have investigation type. So the type of investigation conducted for the event. So whether it is an accident or incident. Accident number. It is the unique identifier of assigned for each accident. Event date. Date of the accident or the aviation of an event. Location. location where the event occurred, country, country where the event occurred, latitude and longitude, where latitude talks about the coordinate of the event location, longitude also talks about the coordinate of the event location, airport code, code assigned to the airport involved if applicable. Next we have the name of the airport, and also we have the injury severity, whether it is a slight. We have the aircraft damage, the degree of damage of the aircraft, whether it is completely destroyed or it is minor damage or it is substantial. Also we have the aircraft category, the category of the aircraft involved, whether it is an airplane or it is an helicopter or it is a rocket. Registration number and unique identifier of an aircraft that is involved, make, manufacture year of the particular aircraft, model of the aircraft, number of engines that is present in the aircraft, engine types, and also we have description based on the Federal Aviation regulations, schedule. Schedule indicates the flight was scheduled or not. Purpose of flight. Purpose of flight indicates the personal or business flight. Air carrier. Name of the air carrier involved, the applicable. Total fatal injury. Total number of fatal injuries. Total serious injuries, and as well as total minor injuries. Total uninjuries details also present, and weather condition details, board phrase, and as well as report status and publication date. So we have almost 31 features that has been provided to us to make an analysis. So let's begin with the project. Let me import the necessary libraries. So let me import NumPy as NP. So as you all know that NumPy is nothing but numerical Python used for numeric and scientific computing. And let me import the pandas library. Pandas stands for panel data. Next we'll import Matplotlib and Seaborn. It is used to make the visualization, charts and graphs in Python. Import matplotlib.pyplot as plt, and let me also import Seaborn. Import Seaborn as SNS. So to overcome the warnings, let me also import the filter warnings to ignore the warnings that is present. So from warnings, import filter warnings. Filter warnings, ignore. So now I have loaded the basic libraries that are necessary for making an analysis. So I will be loading further libraries in later on stages. So now let me import the dataset. So let me assign the variable name or the data frame name as aviation is equals to pd dot read underscore CSV. The data set is present in the CSV format. You can start downloading, that is present in the description, and then you can start working along with me. Let me provide an aviation data.csv. So we have a CSV file. Let me close it and let me execute. I am getting an UTF error. That means there is a case where the characteristics is also present in the particular file, so it is not loading properly. So you can use some of the encoding to overcome the errors. So let me write an encoding called encoding is equals to mac underscore Roman. So now it is successfully loaded. So let me print the top 5 records. Aviation.add. So by default, it is print the top 5 records. So almost we have 31 columns, 31 features. If you want to see the shape of the data, so just write down aviation.shape. So this provides me almost, we have 87,282 number of aeroplanes that has been traveled. So 87,282 records we have, almost we have 31 columns. We can also say that totally we have captured almost 87,282 flights. Its tree has been captured to make an prediction. Right? You are taking almost 87,282 flights history to make the further predictions for our analysis. So I can see here, I cannot see all the column details. I can see there is 3 dots. It is unable to print all the columns because we have almost 31 columns that is present in the dataset. To display all the columns that is present, what you can do, you can just go to this libraries. You can also import a library called pd.set an option. I am setting an option here by stating that where my display number of columns should be 100 or display columns should be 30 or 40 or 50. You can give it manually however you want. So I will tell display the maximum column and I will present as none. So I am not specifying number of columns. I am telling you want to display all the columns. So let me rerun this particular code. You can see I can view all the different columns that is present in the data set. So now we want to start making an analysis with this particular data. So the first thing, once you load the information, start making an analysis. So what are the analysis that we will be going to create right now in the sense, I want to see number of non-null values. What is the total number of non-null count? I also want to see what are the data types that has been assigned for each column. Data types. I also like to see what is the percentage of null values. So percentage of null count. So I want to see or I want to view this 3 information. So how will I do that? First let me create a dictionary called info_dict. So in this info_dict, I will start create the column. Let me create a dictionary format here. So in this dictionary, I will have multiple columns. So the first column name is nothing but the different columns that is present in the aviation. So what are the various columns that are present in the aviation data set? You can just find it as aviation.columns. So these are the different columns that are present in the aviation data set. So I will print it same here, aviation.column. I also want to convert this information in the list format. So I will write as to_list. So it has been extracted in the list format, .toList. I want to assign the variable name. So let me assign this as column. So dictionary stores the data in format of keys and value pair. So I am providing the key name as columns or column and the value I am representing as aviation column. So I have done with all the column details. Along with all the columns, I also want to see number of not null count. I can simply write it as aviation.count. So what is the function of count does? It tries to print the number of non null values. So I will try to add the same information here. First, let me give the column name as not null. Not null count, right? So I will provide the same information here. Let me copy it and let me paste it here. So I will get the details of number of not null counts. Next, I want to see the data types of each and every column. So rather than count, let me make it as data types. So I can simply write it as D types. So D types will provide the what are the data types that are available for the assigned for each and every data. So I will convert this into list format dot to underscore or to list. So the data type is presented in the format of list for me now. I will copy the same thing. I will paste it here. So here I will provide the D types. For each and every column, use the comma separator, and finally I want to see the percentage of not null count. So let me specify the percentage of not null, that is nothing but aviation dot shape. So totally how many records we have? 87 to 82. To extract only this records, what I can do, I can perform the index number 0 because it is a tuple where I can extract the 0th index position. So totally we have 87,282 records minus aviation count, aviation dot count. Along with that, I want to see this in the format of percentage. So I will convert this into percentage divided by aviation count into 100. So now we can see the percentage of null values that are present. So almost latitude has 62% of null values, longitude has 62% null values, airport name has 40% null values, and you can also see here schedule has almost 85% null values and FAR description has 65% null values. So we'll try to deal with all these null values. So let me copy this and let me apply this in particular folder. So let me give the variable name as null percentage. So let me execute this. So this is successfully working fine. So now I will convert this dictionary to data frame. To do that, what I can do, I can simply create a data frame called description is equals to pd dot data frame. I am creating an empty data frame. So in this data frame, I want to add the dictionary here. Let me add the dictionary, info dictionary. Let me paste it. If I execute this, so here how the dictionary or data frame looks like, the description. So I can, instead of index, I can see event ID, investigation type, the column name as printed as an your index position. So what I can do, I can just specify here as drop index or dot reset underscore index. I will reset the index. So once the index is reset, you get the index as a column. So I don't want that column, I want to drop that column. So I will specify as drop equals to true. So now you can see here, you are able to extract these details of description. One is count. So it will, the column is nothing but it prints all the column details. Along with the column, I can see the number of not null count, what are the data types that are assigned for each column, and as well as what is the null percentage, how many percentage of null values that are present for each column. So once you are done with the description, what you can do the next task, that is statistical summary. So to perform the statistical summary, what I can do, I will specify it as statistical summary. So let me write it as aviation dot describe. Let me execute this. So always make sure that whenever you do the describe function, it will try to print only for numerical description only, not for categorical description. So in this numerical description, it states that where we have number of engines is 81,533, the average engine is nothing but 1.14, standard deviation is 0.44, minimum is 0, and number of quantiles, 25th percentile is 1, 50th percentile is 1, 75th is 1, and max is 8. So the same way I can see for all other columns. If you want to do it for the categorical data, you can do it. Just let me copy aviation dot describe. So you can specify include is equals to object, and you can exclude the number. Exclude is equals to empty dot number. So we'll get the details of only the categorical information. So these are the different categorical information data description. So you can see the difference whenever you deal with the numerical data description. It provides the count, mean, that is nothing but average, standard deviation, minimum, 25th percentile, 50th and 75th percentile, and maximum value. Whereas if you start dealing with an categorical data, it provides you the count, number of values that are present, number of unique values, top is nothing but the highest value, and frequency is nothing but more repeated value, how many times it has repeated. So this particular ID has been repeated 3 times, accident has repeated 83,536 times. That's what they have mentioned here. So now we'll talk about the exploratory data analysis. So what do you mean by exploratory data analysis, guys? So exploratory data analysis is nothing but it is the characteristics to understand the patterns, outliers, and as well as facilitating the identification of crucial factors that is present in the data set, where you are going to explore your data and understand what are the trends and patterns that are present in the data. So now we'll perform some of the data cleaning task. The first operation that is presented in data cleaning is whereas removing the data duplicates. Now we'll find whether the data is having duplicates or not. Checking for duplicates. So how do I check whether the data contains duplicates or not? Just I can mention aviation dot duplicated. It will result me in the boolean value true or false. False indicates the data does not have duplicates. True indicates the data contains duplicate values. If you want to see number of duplicate values, you can again perform some indexing operation. Let me write as aviation of duplicates. So you can see there is no duplicate record that are present in the data set. That's good. Once you are done with your checking the duplicate values, now we can find whether it contains missing values or not. You can just specify aviation dot is null dot sum. So extracting the missing values. Checking for missing value. So here you can see some of the columns as missing values. If I want to see only those columns which has missing values, I can just reassign the variable here as miss val, missing values in short. So I will mention miss val is greater than 0. So again this will print the boolean value. I want to perform the index operation. Miss val is greater than 0. So you can see these many columns that contains the missing values. Okay, that's good. So once you found the missing values, now we'll try to perform various operations. For example, we'll try to check what is the null count that are present in the data set, and as well as what is the percentage of null values. So to find the null count, you can specify the variable called null values is equals to pd dot data frame. So now I am creating an empty data frame called null values. Along with that, I also try to specify the number of columns that we have. So as I mentioned before, I will just copy and paste it here to print the number of columns. So these are the columns that has null values dot columns or else index. So these are the column that contains the null values. So what I can do, I can just specify or copy this particular information. I will go and I will create a variable called null values of null count. So that is nothing but these are the column numbers. So let me copy and paste it here, and let me convert this into list format dot to lists. So now your data frame looks like this. So your data frame consists of only those columns which contains the null values. Along with that, I also want to see what are the null count that we have. I will specify null values is equals to, so let me write it down, wherever there is a null values which is greater than 0, right? So rather than index, I will copy the same thing, I will specify the values. So these are the values that we had. Let me convert it into list format dot to list. So now I got the data in the format of list. So let me copy it and let me paste it here. So now we are able to get which are the column that contains the null values and how many null values that are present. Along with that, let me print the percentage of null values. So to find the percentage of null values, again values percentage of null values. That is nothing but where I can specify the list of aviation dot is null dot I'll perform this sum. Now we'll try to display the percentage of null values for each column. So to display the percentage of null values for each column, what I can do, I can just simply write the percentage of null count equals, let me put it in the list format. So let me write as list of aviation dot is null dot sum. So aviation of is null dot sum will give me the boolean value. Whether if you have null values, it will print the true, else it will print the false. So this is how the information prints, aviation dot is null dot sum. So now based on this, I want to extract the number of percentage of null values. So I will write it as list comprehension here, whereas aviation dot is null dot sum, open and close bracket, because sum is a function, is greater than 0. So I am writing some indexing wherever there is an value which is greater than 0. I want to extract only those information dot values dot to underscore list. So now this will extract only those information which has null count. So let me print here. Okay, that's it. We don't have any null values that are present in the data, and we can see here there is no duplicate that are present in the data. Now we'll try to find what are the null values that is present in the data set. So I will extract only those information which has null values. Before that, let me create an empty dictionary. So create an empty dictionary or empty data frame to store columns and their null values. To do that, let me define a variable name called null values is equals to pd dot data frame. So I have created an empty dictionary. Now I will retrieve the columns which has the null values, retrieve the columns with null values and add them in the columns, add them to the columns. That contains to null values data frame. Now what I will do, I will just check for those columns which has contains the null values, and then I will add it to the null value data frame. To do that, what I can do, I can just define a variable called null values of. So I am extracting the column information. So I will specify columns as the variable name. I am creating a new column called columns in the null values data frame equals aviation dot is null dot sum. So aviation dot is null dot sum will extract the information wherever there is a null values. So if I want to extract only those information which contains null values, where I can just copy this information, I can perform the indexing kind of operation which is greater than 0. So let me copy this and let me paste it and let me execute this. So you can see only wherever there is null values, only those information is getting displayed. So now what I can do, I can just extract the value out of this dot index dot to underscore to list. So only those columns got extracted. Now let me copy and paste it here. So it is not null small values, it is a capital letter. So I can see here now the columns, along with the columns I can see what are the columns which has null values. So let me display and show it to you. So these are the columns that contains the null values, almost 27 columns which contains null values. Now we will retrieve retrieve the corresponding values for all the columns, corresponding values for each columns, and add them to null value data frame. Now we'll create a data frame which contains only the null values that is present in those features. We'll try to extract only those features which contains the null values, and then we'll try to display what is the percentage of null values that are present. So to do that, what I can do, I can just write down, create an empty data frame. I will be creating the empty data frame to store columns and their null values. So what I can do, I can just name this variable name as null count or null values. So I will create an empty data frame. So let me write it as pd dot data frame. So I have created the empty data frame. Now let me retrieve only the columns which contains the null values. To do so, let me explain it like step by step how we can perform it. Just write it down, aviation dot is null dot sum. So this will print me the information wherever there is null value, all the details I will get. So but I don't want all the information, I want to extract only those information which has null values. So I will perform some of the indexing operation here. So I will like square bracket aviation dot is null dot sum, which is greater than 0, right? Sum is a function, so write down the sum as a function. So here I have extracted only those information which has null values, right? So if I want to convert this into list format, so let me take only the column names. So to extract only the column names, what I can do, dot index. So only I got the columns which have the null values, and I want to convert this into list format. So I will use dot to list. So I can see I have extracted only those columns which has null values, and I have converted into data frame. I have converted into list. Now I will put it in the data frame, right? So let me name this as null values of columns. So let me paste this. So now I got all the columns which contains the null values. Now what I can do, I want the corresponding values which has null values. So rather than index, what I will do, I will use values. So this is the corresponding column which has null values. Let me name the column name as null values. So capital V, let me replace with capital V here. Always while writing a query, make sure that you are using the proper variable name. If not, it will throw an error because Python is a case sensitive. So let me write as null values. So null values is nothing but this information. So if you execute the null values, you will get these two columns, where the column which has null values along with the number of null values that we have. Now what I want to do, I want to print the percentage of null values for each column. To print the percentage of null values for each column, let me write it down. Displaying the percentage of null values for each column, and we'll add to the percentage of null count. Okay. Well, each column and add them to the null values data frame, right? So let me create a variable. So let me create a variable name called percentage of null values equals to, so let me create a list. So let me specify aviation dot is null dot sum. Again, I will extract the aviation dot sum is greater than 0 dot values. I will write on the same thing, right, divided by aviation of shape. I have done this before, into 100. So you are writing the list of aviation of null dot sum. So you are again extracting the aviation of this dot values, and then you are finding the aviation dot shape of 0 is to 100. Okay. So let me close that and let me click on enter. So this works fine for me. Let me copy it. So these are the percentage of null values. So instead of 0 marks, what I will do, I will remove those values by using the round function. I will keep it as dot round of, let me round it to 2 decimal places. So now we got the percentage of null values. I want to apply this into the data frame. So let me write as null values of, let me create a variable called percentage of null values. So percentage of null values is equals to, let me create a list comprehension for I in PCT null values. For I in PCT of null values, this I want to print the, I will convert this into string format and then I will concatenate with the percentage symbol. Okay. So just to showcase it in the form of percentage. Now your null values look like this. So we have column which has null values and number of null values and as well as percentage of null values, whereas location has 6% of null, 0.6% of null values, country has 0.26% of null values, whereas latitude has 62%, longitude has 62%, etc. So that's what we have already done here, right? Here also we did the same thing. But now what I did, I just extracted the null percentage which is greater than 0. You can also write here, whereas description of null percentage which is greater than 0. So if you use description, that gives you the same results, alright. So wherever the null percentage is greater than 0, that will extract the same information. So both are the one and the same, we can do in either way. So I am explaining the different alternative ways that you can solve this particular problem. So now I can easily get to know that schedule has almost 85% of null values, whereas purpose of flight has 6.63% of null values, etc. So now I am going to treat these null values. So how do I treat these null values? By I will be treating the null values in different ways. For categorical variable, I will be treating the null values based on the mode, and for numerical variable based on the mean. So I will use the simple imputer to treat the null values. So let me bifurcate into categorical variable and as well as numerical variable. To do that, let me write down categorical data, right? So using simple imputer to fill in the null space with the mode values. So as I told you, I will be filling the null values which are present in the categorical data with mode. For a categorical data. So now to fill these null values with the categorical data, what I can do, I will use a library called from sklearn dot imputer import simple imputer. So I am using a library called simple imputer to treat the null values. So it is very easy to treat the null values by using simple imputer. Just you want to initialize the variable here. I am initializing the variable called imputer. You can give any name that you wish. So imputer is equal to simple imputer. Already I have defined it. Just let me call this. And now they are asking me what is the strategy of filling the missing values, whether you want to fill it based on the most frequent values or average, or what are the strategy that you are looking for. So rather than treating it with mode, these are the categorical data, it's better to treat with most frequent value, that is nothing but mode, rather than treating with mean. So what I can do, I will use the strategy is equals to most frequent, right? So that is something but I am treating with most frequent value is nothing but mode. Now I will write imputer dot fit. I am using fit. Fit is nothing but you are asking your model to understand the patterns that are present in the data. You are fitting the model fit aviation dot selected D types. I'll extract only those columns which are object in data type. Because I want to treat only with simple imputer of most frequent with only object column. So if you execute this aviation of select D type of object, it will extract me only the details of categorical data. There is no select D type, there is a select D types, right? So there is no sklearn dot imputer. So I am pu yeah. No model called sklearn dot imputer. Let me write down impute. There is no model called imputer, it is an impute. From sklearn dot impute import simple imputer. So it is initialized here. So let me use a data frame. Data frame is equals to p dot data frame. So let me provide the imputer and whatever it has learned, it want to transform it now. So imputer dot transform dot select underscore D types. So let me specify only the object data types that needs to be performed, right? Object, comma, columns is equals to, let me rename the column names here, aviation dot select D types of object, and let me print the columns. So I am creating a new data frame, p dot data frame, and then I am writing an imputer dot transform dot aviation. Let me create an aviation here. Aviation dot select D types, and let me close this. So now your data frame looks like this. Wherever there is an object data type, it has extracted and then it has then treated the missing values for only the object variable. So if you write down dot is null dot sum, you won't get any null values because now we have treated the null values with object with mode. That is nothing but most frequently repeated items. But you can see here where the number of engine is also an categorical data, right? So if you check out aviation dot number of engines dot unique. So I can see number of engines is also a categorical data. So I want to treat this as well in mode only. So what I can do, the other alternative way apart from simple imputer, I can treat it manually as well. So let me explain the manual process as well. Treating the number of engines with mode, that is nothing but most frequently occurring items. Let me specify aviation of number of engines dot fill any. I am filling the null values based on the aviation of number of engines dot mode and let me specify the index equals to 0, comma, in place equals to true. So I am just treating with mode. So always while you perform the mode, what happens? You will get many values. So I am using index 0 to print only one values. So index 0 is nothing but it prints 1.0 as an output. So I am just imputed the null values with 1.0 wherever there is an missing information that is present in the number of engines. So now we'll do the same thing for the numerical data. So first let me extract the numerical data. So to extract the numerical data, I will do the same thing. Aviation dot select underscore d types. I will write down mp dot number. So I will get only the numerical information. Now I want to treat this numerical information wherever there is null value. I want to treat it with mean. So let me check how many null values are present. Is null dot sum. So you can see here almost 1, 2, 3, 4 columns as the null values. So I will fill the null values that is present in mean. Imputer of numerical is equals to simple imputer. I want to specify the strategy again. So I will write down the strategy called is equals to, I want to fill this by mean. So I will provide the strategy called mean. I want to initialize it. This is your initialization. Once you have initialized, you want to fit your model. So I will be performing imputer of n dot fit your model with aviation dot select underscore d types, and I want to select only the np dot number. So you can specify, copy and paste it if you want. So here I am extracting only what? Only the numerical data. Wherever there is a missing value in the numerical column, I want to extract it and I want to treat it with mean. So let me write as df1 is equals to p dot data frame imputer underscore n dot transform. I am transforming with aviation dot select underscore d types. I'll write np dot number, comma, columns are nothing but aviation dot select d types. Let me copy the same thing and let me paste it here and then do some changes. No need of writing again and again, right? Let me paste it. Columns is equals to aviation of D types. Rather than object, I want to change it as np dot number. Let me execute this. So it is successfully working fine. And now if you check out if there is any null values that is present in the numerical data or not. So I am extracting only those columns which has numerical information. And let me write down dot is null. I have fitted the model, I have not yet transformed it. I want to transform it again. So let me copy this. Here I have fitted it and here I have transformed it. So df1 does not have any null values. So write down df1 is null dot sum. So there should be no null values dot sum. So you can see there is no null values in the df1. So I want to concatenate now df and df1. Concatenating the df and df1, data frame and data frame 1. So you can just write as aviation is equals to pd dot concat. So in the square bracket write down df comma df underscore 1 comma axis is equals to 1. So I want to concatenate this both information in the column wise. So you have provide the axis equals to 1. If it is row wise, you can provide the axis equals to 0. So let me write on aviation. Period concat this one. So let me close this bracket. I have not yet closed. Axis equals to 1. So what is your data frame 1? It is just df and then df underscore 1. Let me check out once again. P dot concat. Let me provide the column that needs to be concatenated. So that is something but df comma df underscore 1. Yeah, it's working fine. Comma axis equals to 1. Okay. Both are the same. By default, axis equals to 1 it will take. So you can go here and you can just write it as aviation as the variable name. So this works better. So now I will check out whether there is a null value that is present in the aviation or not. So it should not, there should be no null values that should be present in the aviation, because just now we have treated the null values. Whichever there is a categorical label, we have treated with mode, and wherever there is a numerical data, we have treated with integer. So let me cross verify once again. I will use aviation dot is null dot sum. So you can see there is no null values that is present in the aviation. That's good. If you want to write it down dynamically, you can just write as mess val is equals to mess val of mess val is greater than 0. So I am just checking out whether the missing values is greater than 0 or not. So there is all the null values has been treated accordingly. Once this is done, we will perform the data visualization operation. So finally, we have treated the missing values. Finally, we have treated the missing values. Now, we will perform the data visualization operation. Data visualization operation. Now, to perform the data visualization operation, firstly, what I will do, I will try to find the aviation accidents per year. What are the aviation accidents per year? So, what are the aviation accidents per year? So, this is my first question. I want to check out how many accidents that has been happened per year, yearly wise. To do so, what I can do, I will first check out the data types of the aviation of year. So, column name is aviation. So, let me copy this variable name dot add. So, you can see here there is an aviation accident here. You should find the column called here. So, let me write it down. Let me find out the event date. Aviation of event dot date dot d types. So, event date is not present, it is telling capital D, not the small d. Let me copy and paste it, right. So, it is in the object data type, but actually I wanted the event date should be in the date time data type. So, now we will start making the visualization. As you know that the data type is not present in the integer format, or it is not present in the date time format, it is in the object data type. So, what I want to do, firstly I want to convert this object data type into date time format. So, how do I convert this object into date time format? Let me write down here. Converting the event date column the type from string to date time. So, let me write as aviation of event date equals to p dot to underscore date. I will use the function called to date time to convert the string to date time, and also I want to provide the column name, that is nothing but aviation dot event date. So, let me run this. So, now it is in the proper date time format. Now, what I will do, I will start extracting the year from the aviation event date. Extracting year from the event date and storing it in another column in the same data frame. So, let me extract the year now. So, let me write it as aviation of year is equals to aviation of event date. I want to extract the year, so I will let me write as dt dot year. So, if you write aviation, you can see here. So, year is extracted, it will be on the last column. So, in the last column, we have extracted the year information. So, what's next? Let me group the aviation dataset by the year and sort it in the event ID column from the group by. So let me perform group by aviation dataset by year and storing the event ID column from grouped data into a surrogate data. So to do that, what I can do, I will just create a variable name called aviation or accident. So I am creating the variable name called accidents, and now I will write the aviation dot group by. So I want to group by what? I want to group by based on the year information. So I will write down based on year, comma, as index is equals to false. I don't want to see the index position, so I will switch off the index and let me take the event ID dot count. Let me count it. This should work fine for me. Yeah. So now what I do, let me filter the columns based on 1982 to 2000 to 20. So let me first plot it, and then we'll see the how the data looks like. Create the line plot. So SNS dot line plot of x is equals to, I will be providing the x as the year information, comma, y as event ID, comma, data is equals to accidents, comma, marker is equals to, let me provide any marker like star. So I can see here is providing me all the accidents that has been happened over the year. But if you see at the beginning time 1950, 1960, 1970 and 1980, there is no such type of airline that is present. So let me see how many information that is present less than 1980. So accidents of year is greater than equals to, is less than equals to 1982. Accidents of this information. So how many records we have? Only we have hardly 7 columns, 7 records. Shape index 0, right? So only 7 information that is present. So the data has been not captured properly. So the actual data is captured from 1980 and till 2020. Again, there is no data captured in the 2020 complete December, right? So what I can do, I will filter out the information here itself. I will specify which is greater than 1982 and let me write down condition and let me write it down accidents of year is less than 2020, right? So if you don't want to extract this information, you can just see how many records are present outside it. Just you can use not operator. So excluding this, how many information we have? Hardly dot shape index 0. So hardly 10 records from 1950 to 1982 and then 2020 plus. So I am removing just first those 20 records or those 10 records. Everywhere the event ID is 1, 1, 1. There is only one scenario that has been happened, one accident that has occurred. So let me remove this. Okay. So let me write the condition here itself. Whereas filtering the column year from accidents data frame. So let me specify the accidents is equals to accidents of, let me specify the column name called accidents of year. Let me, instead of writing manually, I will copy and paste it here. So once this is done, write down execute this. Now this will capture only for the details of accident data which has been happened between the range of or between the duration of 1982 to 2000. So you can see here from 1982 to 2020 the accidents are slightly decreasing format, right? You can see there is a slight decrease in, not slight decrease, there is a gradual decreasing in the accidents which is occurring over the period of time. So this is the inference, we can write it down here. Inference we can see that number of accidents per year gradually decreasing from 1982 to 2020 with peaks and valleys, right? So it is slightly decreasing over the period of time. So next, what you can suggest or what you can say that the decreasing trends suggest advancements in aircraft technology and also the maintenance and as well as pilot training and safety. So we can easily say that there is a decrease in trends that suggests the advancement in the aircraft technology as well as in the maintenance and as well as during the pilot training and the safety. So it is a positive sign that we can say that over the period of time the accidents is keep on decreasing. That's good. Now we'll try to check out aviation accident per month. So which month has the highest accidents and which month has the least accidents? Aviation accidents per month. So to do that, I want to convert into month data type. I want to extract into month data type. Extracting month name. Aviation of month dot aviation just is equals to aviation of event dot date, aviation of event date dot dt dot month name. So here I am extracting the month name. So I am just storing it in the month attributes. So now let me create a plot based on the monthly wise. What is the number of accidents that is going to take place? So aviation of month dot aviation dot value underscore counts dot sort underscore values. Let me sort it in descending order. Ascending equals to false. So the data is sorted in the descending order, and now let me provide dot plot. So what kind of plot they are asking? Let me tell. Kind is equals to bar plot. So if you perform this, can you see here? You can easily say that which month has the highest accident and which month has the lowest accident. Whereas July has the highest accident, August, June, May has the highest accident, whereas February, December and January has the lowest accidents. So we can write down some inference like this. Inference we can see that maximum number of accidents occur in the month of July, August and June and May, whereas least accident occurred in the February, December and January. In the month of February, December and January. So you can also say that more accident that is occurred in the month of summer time rather than in the month of winter or rainy, right? So that is the second pointer, we can also add it. More accidents occur during summer month, likely to increase the traveler and as well as it adds the challenges in the weather condition, likely due to increased travel and challenging weather. So this is how you can see like which month has the highest number of accidents and least number of accidents. Whereas during the summer there is an highest accidents compared to all other months. So now we will try to perform the accidents per day. Aviation accidents per day. So on the daily basis, what is the number of accidents that has occurred, and which day, either a Monday, Tuesday or Wednesday, or which day has the highest accident, we'll try to find it out. So the same way we have extracted the month, the same way I will extract the day name. I can just copy and paste it. Let me copy this and then let me go here and paste it. Rather than month, let me rename the column name as week, and instead of dt.month, let me write as dt.day name. So day name is extracted. Now just I want to plot it. So I will copy this again. I will paste it here. That is not month observation, that made as week. Dot value count descending order and then sorted in bar plot. You can see here during the Saturday and Sunday there is an highest accidents compared to all other months. So what is the inference? You can write it down. Inference. So you can say that maximum accidents that occurs during the Saturday and Sunday, that is nothing but during the weekends. Maximum accidents occur during Saturday and Sunday. That means increased in accidents during the weekends. So we got to know which year there was an huge accidents, high accidents, and which year there was lower accident, and as well as we also saw that which month was having an high accident and which month was very low accident. Along with that, we understood that which day was an high accident and then which day was a very lower accidents. Now we'll try to perform accident per aviation phase of flight. Accidents per aviation phase of flights. So let me write it as aviation of which time there is an IS accident, whether the boarding time or else whether there is an approach of landing or else takeoff. We'll try to figure it out when there is a huge accident, whether during the takeoff or whether during the landing or what. So aviation of board phase of flights dot value underscore counts dot sort values, sort the values in terms of descending order again. So write down ascending equals to false, and let me make sure you are plotting it. If you execute, you will get the values, whereas during the landing time there is a huge accidents compared to the takeoff or other different time. So if you want to plot this, you can just write on dot plot. So kind is equals to bar plot. You can specify bar plot. So if you specify this, if you see here, you can see during the landing there is huge accidents compared to the takeoff and all other time, right? So we want to be very careful during the landing. There is a higher chance of accident occurs during the landing. So let me write the interface inference. inference, whereas we can see that the maximum number of accidents occurs during the landing phase and as well as takeoff. So based on these inference, we can understand and you can tell to the airport industry during the landing and as well as during the takeoff, they should be taking some additional measures in terms of safety. So now we'll try to perform damage type and weather condition. How the damage occur during the different weather conditions. So let me write down aviation of weather condition dot unique. So these are the different weather conditions that we have. One is UNK, IMC, VMC and UNK. So UNK and UNK is both are same, unknown. So let me plot it and then let me explain you. Weather damage. So I am creating a variable called weather damage. So let me specify P dot data frame of aviation of weather dot condition dot group by, and then let me specify the aviation of aircraft dot damage dot value underscore counts. So let me normalize this and let me perform the normalize will print you the percentage of damage. So normalize is equals to 2. Let me write it in 200. So let me close the data frame that has been opened. So aircraft damage. So aviation of aircraft damage. Aircraft damage. So let me print the weather damage here. So you can see various weather condition. What is the proportion of the damage that has been occurred? Those details has been clearly mentioned here. So destroyed is almost like 79% in VMC, and minor is almost 90% in the VMC. Substantial is VMC as 95% and unknown as VMC as 94%. So let me plot this. Weather damage dot location. I will specify destroyed dot plot. Kind is equals to pie chart, and let me use the subplot equals to destroyed. So this how we can see the proportion wise of VMC and as well as with other different categories. Okay, we saw that VMC visual meteorological coordinates has highest percentage of what? Highest proportion of accidents in the damage. So we'll try to do the and check it for all the different what? Damage type. Let me check for substantial, weather damage dot location of substantial, comma. So let me plot it. So kind is equals to pipe chart. And let me specify the subplot is equals to so you can compare with destroyed and as well as substantial. So the same way you can also do it for minor as well. Let me paste it. Instead of destroyed, let me print it as minor. So if you also want to see the percentage wise, what you can do, you can also use auto PCT here. Auto PCT is equals to percentage dot 1F. So you can see how much percent there is a damage. Almost VMC is 79.1% damage in the destroyed. Let me apply the same for other two. Let me copy it. So I can also see here 90% of VMC is destroyed, 95% and as well as 79% in the destroyed, substantial and minor. So I can indicate that I can write some inference here. So always make sure that whenever you do any charts, always you write the description or the inference based on these charts. So let me write it as 79.1% of aircraft which has been destroyed in the accidents were in VMC, that means visual meteorological condition, that indicates the region which has the predominantly clear weather, right? That is what VMC stands for. This indicates a region with predominantly clear weather, whereas in the substantial, I will copy and paste the same thing, but in the substantial it is like 95.6%, 95.6% of aircraft which has been destroyed, which has been suffered with substantially and 90.4% of aircraft has been suffered minor destruction. So these are the inference, we can just write it down. So now let me check with damage sustained. So let me check with the damage sustained. To do that, let me create an variable called damage is equals to, let me create a data frame. In this data frame, let me add down damage of, I'll create a variable called damage sustained is equals to let me write down aviation of aircraft dot damage dot value underscore counts. Let me normalize it to print it in the format of percentage true, and let me convert into 100% dot index. Value counts dot normalize equals to 2. Sorry, rather than equals, I have done minus. So you can just figure it out what is damage here. So it is telling where substantial sustained is these many different information we have extracted now. Based on that, I also want to write the values accordingly. Damage of values is equals to, I'll write it down, aviation of aircraft dot damage dot value counts, and let me specify the normalize equals to true into 100 dot values. Based on different sustained, I am just writing out the values. So substantial as the highest value compared to the destroyed, minor, and as well as unknown. Now we'll also find the injuries over the year. What are the various types of injuries over the year that has happened? So aviation of investigation dot type. So there's an investigation type column. So I'm going to check how many of incident that has happened. So I'm extracting only the incident that has occurred and I'm making an analysis. So injuries for the year, I'm checking out how many injuries that has been occurred over the year. Let me copy this and let me paste here. Incident is equals to, I am extracting only incident information. Now I will write it down. Incident underscore injuries is equals to incident dot group by. I am going to group by based on the year, and I am extracting the total fatal injuries. So let me copy this total fatal injuries. Along with that, I will try to print the total serious injuries. Dot sum, and then reset index. Incident. So let me execute this. So there is a capital Y, here is not defined. Okay. So now I got to know the incident injuries. Let me provide the incident injuries. So I can see here, based on the different year, you can find what is the total incident injuries that has occurred for the total fatal injuries and as well as total serious injuries. So this has printed over the period of year. So if you want to plot it, you can just plot it by using the for loop. So that will give you more detailed understanding. So let me write as for in this information, total injuries in the fatal and as well as total injuries in the serious injuries. So for I in this, also you can specify the minor injuries to print the all three information. Go to the column where we have minor injuries, just copy the minor injuries. So specify the minor injuries as well. So for I in this information, let me plot it, plot, line plot, x is equals to, I will specify the year information, and then y, I will specify the total fatal injury, total serious injury and total minor injuries, comma. I will also specify data is equals to incident injuries. So let me copy it and let me paste it here. Let me close this. So let me print it in Seaborn. So it is telling that could not interpret the year. So let me give this year in the capital. So yeah. So you can see here all the information it is plotted in the same line, whereas we have green indicates. Let me also print the legend here. Legend If you want to print in the separate line, you can also specify here. PLT.X label. You can specify the year information on the x-axis. And on the y-axis, PLT.Y label dot join based on I dot split. So I am splitting based on the dot. That is nothing but I am extracting only the injuries and then total serious, total fatal, and as well as total minor. I am extracting this information. And also let me write it down. PLT dot title so in this title, let me specify the trend over the year dot format. So let me specify the same thing dot join I dot split. I am splitting it based on the full stop. If you want, you can increase or decrease the size of this particular plot. You can specify plot dot figure size equals 15, 7. So now you can see here we have been extracted based on the total fatal injuries. So let me provide the total fatal injuries and the trend over the year, whereas total serious injuries trend over the year, along with that total minor injuries, the trend over the year. So you can see here in the total minor injuries, whereas in the year of 2020 it is very high, but in the total serious injury in the year of 29 it is too high, whereas in the year of total fatal injuries it is peak in the year of 2021 to 2024 or 2026. So you can make some conclusion or you can write some inference here. Whereas a spike in total fatal injuries have been recorded in between the year of 2000 to 2008. It will be indicated that the potential issue during the safety measures of this particular year. So next we can say that a spike in total serious injuries have been recorded in the year between 2007 to 2010. Next, a spike in total minor injuries have been recorded in the year between the year of 1998 to 2002. So this is the description, you can just write it down. These are the inference that we have been formed. So in the year of 1998 to 2002, it has been spike in the minor injuries, and then in the serious injuries 2007 to 2010. You can see here 2007 to 2010 it is increased, whereas in the fatal injuries it has been recorded from 2000 to 2008. So from 2000 to 2008 it is very high. Now we'll try to perform the facilities based on the engine. Based on engine type. So let me write down SNS dot bar plot. So on the x-axis I will be providing the engine type, comma, on the y-axis I will be providing the total fatal injuries, comma, data is I am extracting from aviation, dot group by, I am grouping this by engine type, so we have engine type here, I am grouping this by engine type, and also I am grouping it by total fatal injuries. So I am taking the aggregated function called sum dot reset index dot sort values. So I am sorting these values by total fatal injuries, and let me specify the ascending equals to false. Option has no callable. So let me check out. So SNS dot group by, whereas your X have specified this data is equals to aviation of group by engine type and as well as total injuries, sum of reset index dot sort values by total fatal injuries and as well as equals to false. Total fatal injuries is not available. So what we can do, we can search for the total fatal injuries. Let me copy this and then let me paste it over here. total fatal injuries. So now we can see here, whereas reciprocating has the highest total fatal injuries compared to others. So now we'll try to do some data transformation technique. For the categorical and numerical values. Categorical to numerical values. So here let me drop the unwanted columns which is not been used. So dropping the columns. So what are the columns I am dropping here? I am dropping the publication date, so publication date is not important for me, so I will drop those information, comma. Report status is also not important, so let me drop the report status as well, comma. I will also drop the fare description and model, make I want, let me drop the accident number, this is the unique identifier number, comma. Registration number is also not required. Let me print the registration number, comma. Model is also a unique identifier, so let me drop the model as well. Latitude and longitude. So let me drop it both latitude and longitude of the information, comma, longitude. So we'll drop these many features that are not important for making an analysis. So finally our aviation data looks like this. Aviation.drop columns is equals to, I'll specify the drop, comma. I want to drop column wise, so only I'll specify 1, and I want to affect to the original data frame, so I will write in place equals to true. Let me close this and execute. So this has been successfully executed. Now we are replacing the values with mode, replacing the unknown values with mode. So let me write as for I in aviation, if aviation of I dot D type equals to, if it is an object, then I want to replace it by mode. If it is an object data type, I will write down aviation of I is equals to aviation of I dot str dot title. I will write if unknown, then only, if unknown in what? In aviation of columns, that all the values, if any values as unknown, I want to replace it with mode of that particular column. So if unknown in aviation of I dot value, then you want to fill it by mode. So I'll write as aviation of I dot replace. I'm going to replace this with aviation of I dot mode index 0, comma. I won't affect my original data frame, so I will write in place equals to true. So let me close my dictionary here. It is selling aviation of str dot title. Yeah. So once this is done, now I have replaced wherever there is unknown, I have replaced with mode value. Now I will perform some encoding technique. So encoding helps you to convert the categorical data into the 0 and 1 numerical format. Encoding for target variable. So let me write as aviation of aircraft dot damage dot unique. So let me see what are the unique values that is present in the aircraft damage. So aircraft damage let me copy and paste this variable name. So we have three different category we have. One is destroyed, substantial, and as well as we have minor. So I will replace it wherever there is an substantial and minor. I will be categorizing as 0, 1 and as well as 2. So I am performing a label encoding over here. Replacing the value with target variable. Aviation of aircraft damage dot replace. I am replacing wherever there is substantial. Let me replace it with, or wherever there is minor, let me replace with 0. Let me take it into dictionary format, whereas this is your key and the value is 0, comma, wherever there is substantial, I want to replace it what? With 1, and wherever there is an destroyed, I will be replacing with 2. If you want to affect it, you can just write as comma in place equals to 2. So this has been affected the original data frame. So now extract. Let me extract the categorical data. So extracting the categorical data. Categorical data is equals to aviation dot select D type. Then I will specify the data type here as object. dot, I will extract only those columns, dot to underscore list. So all the columns will be extracted whichever as categorical data type. So let me see what are the columns that are present. Select the types. Okay. So these are the various categorical data we have. Now we want to encode it. So to encode it, let me use label encoding here again. Let me perform label encoding to convert the categorical data into the numerical encoding format. So let me initialize the label encoding. LE is equals to label encoder. So label encoder is not defined. I want to define the label encoder. So in the library, I will go to the libraries and then I will try to import the label encoding. I will go to the top and let me import the necessary libraries as well. So let me import the label encoding from sklearn dot preprocessing import label encoder. So label encoder is imported. So let me import most of the libraries that is required for this project from scipy import stats from imblearn. Let me import the smart from imblearn dot oversampling import smart, and from sklearn dot preprocessing or from sklearn dot feature selection import select k best, and also let me import undersampling as well from imblearn dot undersampling import random under sampler. Now let me also import the variance inflation factor from stats model dot stats dot outliers influence import variance inflation factor variance inflation factor. And also if you want, you can also import the cross validation technique like grid search or else randomized search CV. So from sklearn dot model underscore selection import train underscore test underscore split. If you want to use machine learning model, first you want to divide the data set into two different types. One is training set and the other one is testing set. So I'm using from sklearn dot model selection train test split. So that will split the data into training set and as well as testing set. You can specify the percentage of distributions for training set and testing set. We usually take 80-20 split or else 70-30 split. Now I'm also including the grid search CV. So grid search is one of the cross-validation technique. What is cross-validation? Cross-validation is nothing but you are going to validate your data with different set of training set and as well as testing set. And then we are writing k-fold cross-validation and also basic cross-validation technique. That with cross-validation score, cross-val score. So yeah, so we have loaded all the different models that we require for. Let me also load some of the libraries which is used for building the machine learning model. From sklearn dot linear underscore model import logistic regression. From sklearn dot tree import decision tree classifier. From sklearn dot neighbors import k nearest neighbor. So let me also try to use k nearest neighbor. K nearest neighbor classifier. For now, let me build this much, and also let me build the random forest classifier from sklearn dot ensemble import random forest classifier. So if you want to evaluate your model, once the model is built, you want to evaluate your model, how good your model is performing. So that I will be importing some of the matrices from sklearn dot matrix import accuracy score, comma precision score, comma recall score, comma ROC AUC score, and ROC curve. Can also perform the R2 score and F1 score and confusion matrix. So these are the various evaluation metrics that you can use to evaluate your model. So we were doing the encoding, level encoding. So now let me run this. This works better. Now let me write it as aviation of categorical data is equals to, let me write as aviation of categorical data dot apply label encoding dot, let me fit and then transform it. Fit is nothing but learning, transform is nothing but it is giving the result, where I am telling fit and transform in the both the place one time. So categorical data, let me copy and paste it here. Right, this is successfully performed. Aviation, now the aviation looks like this, where it has been converted all the categorical data into the encoding format. So there is no such type of categorical data anymore. So we have properly encoded. Next, what you can do, you can just find the outliers that are present in the data. So What is outliers? Outliers are nothing but an extreme values, that is nothing but it is not present in the given intervals. For example, if you use this box plot, whereas in the box plot we have the lower end and this is your higher end value, and we can also call this box plot as 5 number summary, whereas in the 5 number summary this we call it as lower end values and higher end values, your first quartile, second quartile and third quartile. Whereas first quartile is nothing but Q1, whereas 25% of the information which is explains less than Q1 and 75% of the information which explains more than Q1. Whereas Q2 or the median is nothing but it divides the data into equal halves, where 50% of the information is less than Q2 and 50% of the information is greater than Q2. Whereas Q3 is nothing but, whereas it is dividing the data set into two halves. One is 75% of the data is less than Q3 and 25% of the data is more than Q3. So this is what the box plot helps me to understand. So box plot helps me to give whether the data set having the outliers or not. So various ways we can find the outliers. One of the ways is by using box plot, histogram. In the histogram, you are going to check whether the data is skewed or not. How can we see? We can see based on the QQ plot also we can see whether the data is having normally distributed or it is skewed. Or else by using the histogram, if the data is asymmetric, asymmetric is nothing but if it is elongated on either side, either on the left side or right side, that means it is not properly normally distributed. If the data is normally distributed, whereas your mean median mode lies in the center. So we use histogram to check whether there is a outliers or not. Also we can use scatter plot and also we can use z-score. So in the z-score you can give the threshold as 3. So whichever value is greater than or less than 3, we can consider that as the outlier. So now let me perform by using the z-score and let me explain you how the z-score works like. Let me define here, define the percentile threshold for deleting outliers. So you are writing percentile threshold is equals to 95% for column in discrete categories. So first let me create a discrete columns. Discrete columns is equals to where we have few columns such as aviation.ed. So we have number of engines. So we can check out with the number of engines. These are the discrete columns, number of engines and total fatal injuries and total minor injuries. Along with that, total serious injuries and as well as total minor injuries. Comma, total uninjured values. So you can see total uninjured. So these are the categorical data I can consider. I will copy and I will paste all this. So for this discrete value, what I can do, I can just perform the descriptive statistics. Now we'll perform descriptive statistics for the above discrete column. So now let me perform aviation of discrete columns dot describe. So I can say descriptive statistics for all these discrete columns. So for the discrete columns, what I can do, I will create a threshold of 95%. If it is less than or equals to 95% of threshold value, then I will consider those are outliers. So for columns and discrete columns, so let me specify threshold is equals to NP dot percentile aviation of column, comma, percentile threshold, whereas aviation of columns, let me copy these columns, whereas aviation of columns is less than equals to threshold value. So let me write that as aviation of aviation is less than equals to threshold value. So I want to perform this operation. Okay. Let me copy this percentile threshold value. Let me paste it here. Percentile threshold. So let me remove this here square bracket. Let me add it over here. So now we are easily able to define the what percent of 95 percentile we have given, and then whichever is what beyond that level. So we are considering that as outliers. So now we can write down the description of the same. Let me copy this. Let me paste it here. So you can see here the number of engines, the count has been completely reduced. So before it was 87,228. Now it has been reduced to this. So whichever having the outlier, it has been removed out. So now we'll perform the simple random sampling. So simple random sampling consists of like feature engineering, whereas if effectively features the engineering can uncover the hidden patterns, capture complex relationship, handle the data limitations, and enhance the predictive power of the model, ultimately leading the better insights and more accurate predictions. So the feature engineering that we are going to perform here is random forest feature importance, L1 regularization, select k-best, recursive feature elimination, variance inflation factor. So these are the various ways that you can perform the feature selection technique. So why do we perform feature selection technique in the sense? For example, consider we have like thousands of features. We cannot input all the features to the model, right? So if you give all the information to the model, there may be chances of curse of dimensionality can be created. So what you can do, you can just select the important features and then you can feed it to the model. So the model can learn or train from that, and then it gives the proper predictions. So feature selection is very most important. Let's select the features. In the feature selection technique itself, we have various methods. One is filter method, wrapper, embedded, and hybrid method. So each method has its own functionalities. So now I will be using the VIF, variance inflation factor, to do the feature selection technique. So let me create a VIF, that is nothing but variance inflation factor. Let me define the variable name as new aviation is equals to aviation dot drop. Let me drop event date, comma, aircraft dot damage, comma, axis equals to 1 to drop the columns. Now let me specify, create a calculate out VIF, variance inflation factor, calculate the variance inflation factor for each predictor variable. So VIF underscore score is equals to P dot data frame. So let me create an empty data frame. Now what will I do? I will create an VIF score is equals to, let me add the feature names. Features or feature is nothing but new aviation columns, new aviation, let me copy paste it, dot columns, VIF scores. Let me try to print the VIF scores. Let me write down a simple list comprehension here. Let me write down for I in range of new aviation dot shape of 1 I want to specify variance inflation factor of new aviation dot value, comma, I new aviation is not defined. Let me copy this new aviation. Let me print new aviation and new aviation. Yep. So now let me print the VIF score. Printing the VIF score. Print VIF scores. So these are the VIF scores. Now based on these, we can create a threshold called 5, 10, 15, and then you can filter out the some of the columns as well. So now let me specify the threshold for this VIF. Set a threshold for VIF. Threshold I am setting it as 15. So now whichever is beyond the threshold limit, I will going to drop those column. So select features with VIF below the threshold value. Let me write as selected features is equals to VIF underscore scores. So let me write as VIF scores of VIF variance inflation factor is less than threshold of So if you execute, that will extract all the information. I don't want all the information, I want only the feature information. So I will extract only the feature information. I will use square bracket, extract only feature dot values. So once it is done, so now create a new data frame with the selected features. Create a new data frame with the selected features. So let me write down new aviation is equals to new aviation of selected features. Let me copy these selected features and let me paste it here. New aviation. Let me paste it, new aviation here. Let me run this. So I am able to create the new aviation of X. So these are the columns. Finally, we end up with 17 columns and we ended up with 71,456. We have removed some of the records which are having the outliers, and also we removed some of the columns which are having highest variance inflation factor. Why we use the variance inflation factor? In the sense when the data is having highly multicollinearity. So what is multicollinearity? When the two independent features as highly correlated with each other, then we call that feature as a multicollinearity feature. So while building the model, we don't even want the features should have multicollinearity. So for an example, consider you have A and B. If both A and B is telling the same information, so you can drop any one variable and keep the other variable to build the model, right? So that is the behind the scene that what happens here is. So now we'll concatenate the information. So let me concatenate the new aviation X and aircraft damage. So aircraft damage, I have dropped it because that was the target variable. So I have dropped this aircraft damage. Now let me combine this both. Aviation is equals to PD dot concat. That is nothing but we are concatenating the new aircraft X, comma, the aircraft damage aviation of aircraft damage, comma, axis equals to 1. So I want to combine this column wise, so only I have written axis equals to 1. Now let me select this aviation and let me print the aviation. So the aviation will look like this. Now at last we have 18 columns. Now we'll try to perform the multi-class classification problem statement to binary classification problem statement. Now we'll convert multi-class classification problem statement to binary class where we'll write down aviation of aviation dot damage dot replace. I am replacing Wherever there is 1, I am replacing with 0, comma. Wherever there is 2, I am replacing with 1. So that means what I have done here is, so we have 3 different stages, right, at the beginning in the aviation. One is fatal injuries and as well as severe and as well as severe damage and minor. So let me take this up at the beginning. So destroyed and as well as we had other 2. Let me scroll down. So one is destroyed and the other one is suffered and as well as we have minor. So suffered and minor we have make it as one category and destroyed as the other category, and then we are dealing it now. Comma, in place equals to true. Aircraft damage, aviation damage. Not aviation damage, aircraft damage. So now we'll split the data into training and testing set. Train, test, split. So we are going to split the data into training set and as well as testing set. So train, comma, test, comma, train underscore, test underscore, split. Here I will provide the aviation, comma, let me specify the test size is equals to 0.2, 0.2, comma, random state is equals to 42 or anything that is your wish. Random state you can give anything. Now let me specify the, let me run this. So this is how your train and test look like. It has been split into training set and testing set with 80% of training set and 20% of the testing set. Now let me extract the x train and y train value. Train of x is equals to train dot drop aircraft dot damage, comma, axis equals to 1, comma, train of x, y is equals to train of aircraft damage. So now I am extracting, this is your dependent variable and this is your independent variable, whereas x in the independent variable and as well as y is a dependent variable. You have performed these operations. Now I will do the same thing for test as well. Test of x is equals to, rather than train dot drop, I will perform the text dot drop. Test dot drop this, and then I will do the same thing for test of y. Rather than train of y, I want to change it for test of y. So here I will specify the test of air damage, aircraft damage. So now I have been having the train x, train y and test x, test y. So if you want to see the shape of it, you can just specify the train underscore x dot shape. So this is the shape of the train, and then if you want to print it out, you can print it out. Train of x dot head. So you can see this is your train information. You can check the same thing for test as well. Test of x dot shape. So this is your text x dot shape and as well as train x shape. I want to do this same for y as well. Let me change it to for y. So equally it is divided with 80 and 20 split. And now we'll see whether it is equally balanced or imbalanced data set. Let me specify train underscore y dot value counts. So if we specify the value counts, it is like 46,000 of training set and then 10,000 of testing set. That means let me use normalize equals to true to print the percentage. And let me multiply this with 100. So 81% of the data in the 0 and 1%, 18% of the data in the class 1. So the data is imbalanced, 81 and as well as 18%. So we have various methods to handle the imbalance. We'll be dealing with those methods as well. Some of the methods as undersampling, oversampling, synthetic minority oversampling technique, Tomac link. So these are the technique or can be used to handle the data imbalanced. So we'll be learning one by one. Now this is how your predictive analysis looks like, whereas we have precision recall, whereas we positive and negative clause and positive and positive clause, negative with negative clause, negative with positive clause. So now I'll use logistic regression as the model and let me try building the base model, logistic model. So in this logistic model, first I want to initialize my logistic regression. So let me write as LR is equals to logistic regression. So I'm initialized my model. Now let me specify LR dot fit. I'm fitting the train of x comma train of y. So I'm fitting the train and as well as x train and y train. So while fitting your model, fitting is nothing but you're making your model to learn and understand the pattern. You're telling your model to learn the pattern. Once the model is learned the pattern, you're asking the question to a model. So the model is able to predict it. So now prediction. For prediction, we are giving only the question. It should be able to print the answer. For an example, during your classes, what we do, we give you question and as well as the solution file while practicing. Once you have learned the topic, we give only the question and test how good you are performing. Right? The same thing we are going to perform here as well. In a prediction, you are specifying YLR is equals to LR dot predict of test underscore x. So now let me print the accuracy for this. Accuracy of LR logistic regression is equals to accuracy underscore score of test of y comma YLR into 100. So accuracy score is not defined. Yeah. So now let me print the accuracy of logistic regression. So the logistic regression accuracy is coming around 84%. That's good. But if you see the, let me check it for precision and recall for the same. Because the data is imbalanced. Whenever the data is imbalanced, accuracy is not the right metrics to choose. We want to use the precision and recall. So let me check with the precision. Precision of logistic regression is nothing but precision score train y comma y underscore LR into 100. Precision of LR. Found the input something. Let me copy and paste it here. Sorry, I have provided train Y. It should be a test Y, not train Y. So now let me search for recall. So rather than precision, recall of LR, recall of LR with recall score. So recall score, you can compare it. It is just 21%, but precision is 72%. As I told you before, whenever the data is imbalanced, where accuracy is not the right matrix to choose because your recall is very low. So I can say that the logistic regression is not the right model for this particular problem statement because it is not predicting properly on the recall. Let me print the F1 score. So F1 score is nothing but an harmonic mean. So it gives the same weightage for both precision and recall. So let me perform F1 score underscore logistic regression is equals to F1 score of test of Y, comma Y of LR into 100. So let me check the F1 score. So you can see the F1 score is very less, that is just 32%. So you can easily say that the model is not the right fit for the particular problem statement. So we want to go for different models. Before trying to with the different model, let me print the confusion matrix here. Confusion matrix of LR logistic regression is equals to confusion matrix of this values into 100. So let me print the confusion matrix here. So you can see here how much positively correctly predicted, negatively correctly predicted, it has been displayed here. So this is fine. So now we'll try to use another model. Apart from logistic regression, we'll try to go for decision tree. So you can see now the logistic regression did not perform well because the data was imbalanced. So what I can do, I can balance this data and compare it once again. So that I will be using undersampling technique. We can use various techniques like undersampling, oversampling, synthetic minority oversampling technique, or else Tomac link. These are the various techniques used to handle the data imbalance. For now, let me use random undersample and then check out how the model works for random undersampling. So let me write it down. Under sampler is equals to random undersampler. We have loaded the library called random undersampling. So I will give the random state as 42. So now let me specify the train of x, comma train of y is equals to undersampler of fit underscore resample train of x, comma train of y. So what undersampling does in the sense, we'll be having two different class, one is majority class and the minority class. So the value of majority class, consider you have 300 record and value of majority class is 10,000 record. So the final outcome will be like in the value of A will be 3000 and value of B is also 300. 3000. So it randomly removes the record from the majority class. That what undersampling does. In the majority class, it randomly removes the record from the majority class and they make the minority class and majority class equal. So let me write down train underscore y, not train comma y, right? So let me do it the same thing for test of x comma test of y is equals to, let me print the same thing, undersampler of fit of, rather than train, let me specify the test of x and test of y. Now let me print the shape of this. Dot shape dot shape and majority class also, let me print the shape of it and dot shape. So I can see here so let me write as test of y dot value counts. So this is the test value count, test of y value counts after performing the undersampling, because it has removed the random records which is present in the majority class and then it made equal to the minority class. Now if you want, you can check the performance of the model by fitting the model once again. So let me copy this, let me paste it. So train of x and train of y, and again I am rebuilding the model, and let me copy the accuracy score, print the accuracy score, and print the precision and recall. Let me copy the recall information. Precision, and let me print the recall. So you can see here precision and recall is slightly improved because the data was imbalanced before, now the data is balanced. So compared to before, it is increased a lot. Along with that, you can also find the F1 score. Let me print the F1 score value. So F1 score is also 71%. Before it was 33%, now it is 77%. So you can see here the model has been gradually increased its performance after performing the undersampling. So now we can start understanding about the decision tree. A decision tree is also known as a tree which has root node, branch node, and as well as leaf node. Whereas in the decision tree, it takes all the data set as an input, and then based on the information gain, it selects the root node, For example, consider you have 5 different nodes or 5 different features. Whichever whichever feature has the highest information gain will be selected as the root node, and then it start splitting the tree until it reaches to the branch leaf node. Leaf node is nothing but terminal node which has only one kind of nature. There is nothing but until you get the homogeneity split. It will be keep on splitting. But the problem in decision tree is that where the model will tends to overfitting, because it start building the tree or it start building the information to its complete depth. There will be chances, usually the tree may tends to overfitting. At that particular case, you want to perform an pruning technique. Pruning is nothing but a cutting down the branches of the tree. Now we will try to utilize the decision tree. Let me specify, initialize the decision tree. dt is equals to decision tree classifier. So let me copy everything here, and every parameters is same, only the initialization will be different. So rather than LR, I will be changed to decision tree. Here also I will change it as decision tree, and let me change here as well to decision tree. Okay. So precision decision tree is not defined. So you have your decision tree. Always if you get an error, start reading the error and try to solve it. So you can see your precision and recall is almost same, like 75% and 75%. So the model is perfectly working fine. It has not been overfitted. It is like properly the model has fitted. So if you want to boost your performance of the model, you can also use hyperparameter tuning technique. For an example, let me use some of the hyperparameter tuning technique. Let me provide a parameters is equals to, let me provide in the dictionary format. Let me go and select the criterion. Criterion is nothing but where your model should be an ID3 algorithm or CART algorithm. You will be selecting based on the criterion. So we have entropy and as well as Gini impurity. So let me write down criterion. Criterion, that is nothing but where we have list of elements. One is Gini, and also we have entropy. Entropy is nothing but ID3 algorithm uses the entropy as an selection measure for an attribute. Entropy is nothing but it is an impurity or uncertainty that is present in the data. So the range of entropy lays between 0 to 1. Now we have max features or max depth. So max depth is nothing but one of the hyperparameter tuning technique. It allows tree to grow to the number of depth. If you don't provide the max depth, the tree will grow to its complete depth. So you can provide the max depth as 5, 10, 20, that is completely your wish. I will also specify the minimum samples split. So minimum sample split is nothing but, let me specify 5 and 10. So minimum sample split is nothing but the minimum number of element needs to be present if you want to split down the tree further. So now let me specify grid search here. Progress. So now we'll try to use grid search CV, one of the hyperparameter tuning technique. So let me write on the grid search CV. Grid search is equals to grid search CV of decision tree. I am using decision tree here. I will provide the parameter as criterion is Gini, and then entropy, max depth as 5, 10, and the minimum split as 5 and 10. So let me specify the same thing, same parameters, and cross validation is equals to 5. So let me close this, and now let me fit my model by using grid search. Dot fit. So let me provide the both training and testing value. So let me copy and let me paste it here. So let me specify the best parameters out of this by writing params is equals to grid search dot best underscore params underscore. If you specify this, it will print the best parameters out of it. So you can just write down what are the params here. So the best parameters are criterion is Gini, max depth is 5, minimum sample split is 5. So if you want to see the score of this best parameter or the maximum score that we got in the grid search, you can just specify grid search dot best underscore score. So the best score that we got by using the grid search is 83%. You can write down into 100. So this is how we can improvise the performance of your model. Initially, the performance of the model was 75%. After using the hyperparameter tuning technique, the model got enhanced. It has been improved to 83.30%. Now we'll do the same thing for random forest. So now I just did only for the training set. I did not perform for testing set. Let me do the same thing for testing set as well. Let me specify DT is equals to decision tree is equals to decision tree classifier, and let me take the same parameter that has been used. So if you want to use the same parameter that we got, you can just specify star params. So it will take the above params that has been used. So now you can just specify DT dot fit of train of x comma train of y. I am now fitting the model with this best parameter, and then let me ask to predict it dt dot predict probability with test x. Let me execute this. Predict probab. So sorry, I've used capital P. Predict underscore predict probability. So it is printing the probability. You can take any one, either x or y. So this is your probability of 0 and this is the probability of 1. Let me take all the rows with first column. I am just taking this 0.3, 0.037, 0.089, etc. So from this I am just checking out if it is greater than the equals to threshold. So let me specify the threshold as 0.33. So I am just considering the threshold as 0.33. If it is greater than this threshold value or not, let me write it down. So everything is false and the remaining is just true. That's fine. Now we'll perform the accuracy of the model. Let's see off. Accuracy score of test underscore y, comma, y underscore dt into 100. So accuracy score is 75% for the best parameter model, and we'll see the same thing for precision, recall, etc. Let me execute this. So precision is 75% and recall is also 75%. So this is working good compared to the before model. So before the model was 72 and 74%, and your F1 score is 71.95%, but now the model got improved with 75% as my F1 score. So this is how you can improvise your model performance by using the various hyperparameter tuning technique, and then you want to check out whether the data is balanced or imbalanced. If it is an imbalanced data, you want to balance it by using the undersampling or oversampling technique. Now the same operation, let me perform it for a random forest. So let me write down a random forest classifier. RF is equals to random forest classifier. So rather than writing it manually, let me copy paste it. Already I have written all this information on the top. And let me change it. Wherever there is DT, I want to change it for random forest, RF. That's it. Now you can see I am just changed wherever there is decision tree, I am just changed to random forest. So the performance of the random forest is quite better compared to the decision tree and logistic regression. It is also printing the 81% as your F1 score, but recall is performing better compared to the precision. You can also use hyperparameter tuning technique for the random forest model. So let me use parameters such as parameters is equals to, I can specify various parameters such as n estimator, that is nothing but number of estimators is nothing but number of trees, number of decision tree that you are going to build, n underscore estimators colon. So you can specify the list of estimators. So let me provide 100 comma 200 for now, but it takes a lot of time to process. Max depth also let me specify none comma 5 comma 10, and also let me specify the minimum sample split colon. I will specify the minimum sample split as 5 comma 10. So let me run this. This is your parameter. So let me use the hyperparameter tuning here by using the grid search. Let me copy the same thing that has been used for random forest. I've used grid search somewhere. Yeah. So let me paste the same thing here. So rather than dt, I will write as random forest. So parameters is the same parameters I have called out. So if you execute this, first we want to initialize the random forest, RF as initialized, then parameters. This is the parameters I have given, cross validation, grid search CV, model.fit. So grid search dot fit train of x and train of y. Why it is telling train of x is not defined? Grid search dot fit the model. I'll specify the train of x, comma train of y. So we are getting an error by stating that there is no minimum sample split. There is a minimum sample split. Just you can copy it and you can just print it here as minimum sample split and you can perform the operation. Let me execute this once again. Yeah, it is taking, it is accepting now. So let me fit my model. So it takes again a lot of time to fit my model because it is splitting almost like 100 decision trees and 200 decision trees with complete depth to its complete depth and as well as to a depth of 5 and to its depth of 10. And again it is taking the minimum sample of 5 and as well as minimum sample split of 10. So multiple model it is building in the backend. So it takes a lot of time to process it. So until it processes, let me discuss what all we have covered today. So at the beginning, we started with analyzing the data for this particular problem statement and we started collecting the data from different files, and then once the data is collected, we perform the exploratory data analysis, that is nothing but EDA. In exploratory data analysis, we started cleaning the data and we started visualizing the data. We understood various factors from the data visualization. Then we did some of the statistical summary and then we performed the feature engineering. In this feature engineering, we handled the missing values. We handled the outliers by using the Z-score. Along with that, we perform the feature scaling technique and also feature selection technique. In handling the outliers, we identify the outliers and also we treated the outliers. We removed which are the values which are having the outliers, which is greater than 95% of threshold values. Then we perform the random sampling and then we started performing the predictive analysis classification. Then we started building the logistic regression, decision tree and random forest. And finally, we are going to conclude it. So random forest takes a lot of time to process it because it is building too many decision trees. Also, we started performing some of the technique called SMART because of the data imbalance issue. So we can conclude it for now, whereas almost the highest accuracy that we got from random forest with an, yeah, now we got to know the what grid search has been successfully run. So this is your random forest classifier, it has been performed. Now I will checking the performance of my random forest based on the highest hyperparameter that has been performed. So let me take this best parameters and let me print the best parameter out of it. So the best parameter is max depth is 10, minimum sample split as 10 and number of estimator is 200. So based on this, I will build the model and check how the performance of my model is. So let me copy it, whatever I have performed just now. Let me paste it here. Rather than decision tree, let me write as random forest and then random forest. Let me fit my model. Random forest classifier. Let me execute. It is fitting the model based on this parameters. So once the model is fitted, We'll try to ask for prediction. Let me copy it and let me paste it. rf.predict your x-test accuracy of your random forest. So F1 score is 82%. Before the F1 score was 81%. Now the F1 score is slightly improved with 82% based on this hyperparameter. Whereas your accuracy is 83% and precision score is 75% and recall score is 79%. Whereas your ROC F1 score is slightly improved compared to before. Now we can conclude by stating that whereas random forest was performing better compared to decision tree and logistic regression. Thank you.